This video goes over exponents. Before we start with exponents, let's talk about multiplication and addition. So if we were to add the same number over and over again, for example, 2 plus 2 plus 2, repeated addition, we learned in elementary school that that's a shortcut version of writing that as multiplication, right? 2 plus 2 plus 2, and that's the same as 2 times 3. Now exponents, that's actually repeated multiplication, right? 2 times 2 times 2. We can use exponents to write that as a shorthand. So that would be 2 to the third power. So repeated multiplication is what exponents show us. A little more vocab here. The exponent is obviously on the top, exponent, and then the bottom number, that's called the base. So the exponent is repeated multiplication of the base. This entire thing here, this is called exponent form. And this would be its expanded form. So again, exponents stand for repeated multiplication of the base. So whatever the base is, you're going to multiply it by itself that many times. So 2 to the third power would be 2 times itself 3 times. All right. For 6th grade, besides basic exponents, you also need to know something to the 0 power. So for example, if I have 3 to the first power, that's just equal to 3. 3 squared, that's 3 times 3, or 9. 3 to the third power would be 3 times 3 times 3, which is 27. Now we can look at patterns to figure this out, right? To go from left to right, we're multiplying by 3 every time. And we can use this pattern to help us figure out 3 to the 0 power, right? Because if we're going to go backwards, if I go backwards here from 27 to 9, instead of multiplying by 3, I'm dividing by 3, right? So from 9 to 3, I am again dividing by 3. This means that 3 to the 0 power, I would follow that same pattern. I would divide by 3, which gives me 3 divided by 3 is 1. I double check to see if the pattern works both directions. And it does, right? 1 times 3 is equal to 3. Now you'll notice that this works for any number, right? If the base is 5, you're going to multiply by 5 and divide by 5. And over here it would be 5 divided by 5 is 1. So 5 to the 0 power is also 1. If you do like 7, for example, this number 7 to the first power would be 7. Divided by 7, you'd also get 1. So 7 to the 0 power is 1. So therefore, any number besides 0, any number besides 0 raised to the 0 power is equal to 1. All right. You can't do 0 because this would be 0. 0 to the first power would be 0, and you can't divide by 0, right? The pattern doesn't work since you can't do 0 divided by 0. So 0 to the 0 power doesn't work. Every other number to the 0 power is equal to 1. So for example, if I give you like 200 or 257 to the 0 power, you just turn your brain off. That is equal to 1, right? Any number to the 0 power is equal to 1. Okay, this is what you need to know for 6th grade. If you want to go a little more advanced, then we can talk about negative exponents, right? What would 3 to the negative first power, 3 to the negative second power, and 3 to the negative third power look like? Well, we would just follow the same pattern, right? We would continue to divide by 3. which means this would be 1 divided by 3. I'm going to write that as a fraction, 1 over 3. And then if I divide by 3 again, then I would get 1 over 9. And then you divide by 3 again, and you get 1 over 27. Notice the symmetry, I would say, right? 3 to the first power is here, 3 to the negative first power is here, right? 3 squared is here, 3 to the negative second power is there. You see the symmetry? 3 cubed is here, 3 to the negative third power is there. So one common misconception is that negative exponent means a negative number, when in reality, negative exponents means fraction. It's 1 over 3 to the first power. 3 to the negative second power is 1 over 3 squared, right? 3 squared is 9. And 3 to the negative third power is 1 over 3 cubed. And 3 cubed being 27. So that's this part, negative exponents, a little extra. If you're aiming for one of the more advanced courses next year, this is something you should know. But if you're just aiming at 6th grade, then this is TMI right now. You'll learn this in future years. All right, a little more extra info. To get even more advanced than that, we have something called the power rule. Oh, sorry, not the product rule. The product rule. So for example, if I have 3 squared times 3 to the third power, right? The product rule, because it's called the product rule because product is multiply. I'm multiplying. So whenever you're multiplying something, two different exponent forms with the same base, you can really just add the exponents. I'm going to do that without it. So 3 squared is 3 times 3. And then 3 cubed is 3 times 3 times 3. And if we're multiplying the whole thing together, that's just equal to 3 to the fifth. And the product rule says this. 3 squared times 3 to the third is 3 squared plus, or 3 to the second plus third power. So if you're multiplying two of the same base, all you do is add the exponents, 2 plus 3. And that's shown with the work here, right? 3 squared is 3 times 3. 3 cubed is 3 threes. So if I multiply all of it together, it's 1, 2, 3, 4, 5 threes, or 3 to the fifth power. And the shortcut is 2 plus 3. We can also do this with exponents, right? X to the fifth power times x to the seventh power. If I do the product rule, then this is x, because they have the same base, x to the 5 plus 7th power, which is equal to x to the 12th power. All right. That's it for notes. Good luck on practice.